Okay, now we're doing section 9.4, question 11, and we have to determine which of the equilibria are stable and which are unstable. And so let's graph this, and this is P, and we've got a 0 at 3 and another one at 0. And the right-hand behavior's up, since the product, the leading coefficient's positive, and we're going to go through each of the zeros because no bounces. And anyhow, so here P prime is greater than 0. Here P prime is less than 0 because we're below the p-axis, and here p prime is greater than 0. Now, let's take in the second derivative and see what we get. So, d second derivative with respect to t equals, and it's going to be 4p p prime minus 6p prime, which equals, factoring a 2 and a p prime out of each term, we get 2p prime times 2p minus 3. And now replacing p prime with its identity, we have 2 times 2 is 4p times p minus 3 times 2p minus 3. And now let's do another number line, p, and the zeros of this are, well, one is 0, the other one is 3, and 2/3 or 3/2 is also a 0 as this, 3/2. Now, if we multiply this out, the leading term will be positive, so we're going to start from above. We're going to go through 3/2, come out, go through 0, and so this is positive, negative, positive, and negative. And so p double prime is greater than 0 here, as is p prime is greater than 0. Here, p double prime is less than 0, whereas and p prime is less than 0. On this interval, p double prime is greater than 0, but p prime is less than 0. And on this interval, p double prime is less than 0, and p prime is greater than 0. So now, let's do a diagram of the behavior relative to these equilibria. So, and I think I'll just leave this much of it. And we'll do our diagram. So here we are at 0, 3/2, and 3. And according to this, if we're below 0, then both the p prime is greater than 0, but p double prime is less than 0. So it's going to look like this. Concavity's down, but the slope is up. Okay, let's go for the next interval, and I'm going to start here. And if p prime is less than 0, but P double prime is also less than 0. So we're concave down and we're going down. And then on the interval below 3/2, our slope is still 0, but our concavity's up, so it's going to look like this. So consequently, we have something looking like that. Okay, and if we're above 3, then the concavity's up and the slope is up, and so consequently, this is unstable, and 0, the equilibrium 0, is stable. This is attracting, whereas this is repelling, and we're done.